Okay, so I'm going to entitle this part. Let me make the screen bigger. And by the way, is it okay if I turn out that last light on that side to make the screen have a little bit more contrast to it so you can see it better? Okay, so here we go. Turn that out. And then I'm going to hype you up a little bit and say the beautiful, actually, I'm going to add a word. I was going to say just the beautiful language of math, but I'm going to say the beautiful and efficient. The beautiful and efficient language. Wait, hold on. Let me make my pencil width thinner because it's so thick it's hard to write nicely. Okay, so what's the beautiful and efficient language of math? So first of all, there's 5 symbols we're going to learn. This symbol, this symbol, this symbol, this symbol, and this symbol. So what do those symbols mean? So I'm going to list them in order 1, 2, 3, 4, 5. There we go. 1, 2, 3, 4, 5. And the 1, 2, 3, 4, 5, that's called the precedence. The precedence of logical operators. So what do you have logic for? Operators. What do you have logic for in life and in math as well? Well, logic helps you break down truth, basically. So what is truth? Who remembers who said what is truth back a long time ago when Jesus was about to get crucified? Who remembers who said what is truth? So let me put that in quotes. What is truth? Well, that's just you can't really answer that question because it's too big, because truth is probably too big to define. If you could define it, then you'd be in charge of truth and you'd be God, I guess. So what is truth is too big of a question for us to answer right now, or maybe at all. But we can clarify what's something that can be true or false. What do you call something that is either true or false, but not both? Something that's the only things that can be logically studied or analyzed are something that's true or false, but not both. There's several words for it. When I was learning this, they called it a statement. Something that's true or false is called a, now that this book uses the word declarative sentence. Or you could say a statement. And you could also be even more specific and say it's a proposition. And sometimes something that's true or false can be defined to be a variable. So just like in math, you can define a number to be equal to a variable. You can also declare something that's true or false, but not both, to be called a variable. They can be called propositional or sentential variables. Now, have you ever studied AI? What would it be called if you had a sentential AI? Something that had its own like awareness or something like that. So these variables are basically variables that have to do with like intelligence, kind of. So they're called the propositional sentential variables. And they just use, for those, they usually use the letters P, Q, R, and S. So for numerical variables, we usually use X, Y, and Z. For these variables, propositional variables, we usually use things like P, Q, R, or S. We don't usually do more than 4 at once, but if you did, you'd have to use more letters than those. So first of all, what is that first logical operator called, and what does it apply to? It applies to a propositional variable. So this variable right here is called not. So whenever you have something, you could also not have it, right? So let me give you an example of a propositional variable. So let's say the propositional variable called P is the statement 2 equals 2. So is that statement either true or false? Is it true or false? Yes, it is either true or false. And it doesn't matter to us right now which one it is. It's either true or false, but not both. So it's a propositional variable. So first of all, is P equal to true or is P equal to false? Well, actually, it doesn't matter which one it is, but it's a propositional variable because it's either this or this, right? Let me give you another one. Let's say Q is that Q is the statement this is not true. Is that a propositional variable or not? Well, if it's true that this is not true, then it's actually true. But if it's true, then it's not true that it's not true. So it can't be, it's logically inconsistent, right? The logically inconsistent things cannot be a valid proposition. Cannot be a valid proposition. So, like that. All right, so can anybody think of another thing that would actually be a valid proposition?
This is true.
This is true. PQR. This is true. You know, that's actually, I'm not quite sure about this. I think this is like a logical conundrum because this is self-referential truth. So if you say that this is true, then it is true because it says it's true. So if it's true, then it's true that it's true. But you don't know for sure if it's true though. So if it's really false, then it actually is false because if it's false, then it's saying something false because it's actually false, but it says that it's true. So since you don't actually know what since it's a pronoun this, you don't actually know for sure if it's true. So I think this is what they call an undefined proposition. Like it's not, you can't really say that it is true or that it is false because it doesn't have a definite definition just because it. So the other one's definitely not a valid one. This one is like an undefined. I'd probably put this down as like undefined, kind of like dividing by 0. So this is true, I'd say is undefined. You probably find people who might say that it is defined because they say, well, you just have to believe that it is true. Let's try to think of something else that's a valid proposition. Actually, what's another valid proposition? PQRS. Now, if something is a proposition and you don't know the answer to it, is that still possible to be a valid proposition? I think it actually can be, as long as it's still clear. So the first one maybe is probably undefined. This one's undefined because nobody knows exactly what this is. So you can't really for sure know if this is true or not. But what if I said something you didn't know, like how many people are living how many people right now at this very second are in Africa right now? We don't know, right? I'm just gonna say 999,797. That's maybe add a couple more. 45. 451. People are in Africa. People, I say people in Africa. Now, we don't exactly know, nobody exactly knows how many people are in Africa right now because more people might get born or more people might die every single moment. But that's still either true or false, right? So the statement, the proposition S is either true or false. So it is a proposition because it's a clear statement it can only possibly have either one value, it's either true or it's false. Clearly, it's either true or false and not both. So, maybe actually the third one could be, I think ones like this are actually kind of confusing because it depends on, there's a lot of like philosophical arguments about that. So this is true, maybe it's actually true because it's either true or false and not both, right? This is true. It could be true or it could be false. Well, maybe I should go back and say this actually is a proposition. I'm going to say maybe. Although it's not really a well-defined proposition. I think some books go a lot into something called being well-defined, which means that you don't have unclear words like something that you don't know for sure whether it's true or not. So for the reason that this one is always not a valid one is because it doesn't matter what this is, whatever this is, whether it's true or false, it still comes out to be a contradiction to itself. The second one, though, you don't know what this is in it, and so it's maybe not clear. All right, well, so those are some propositions. Now let's talk about what the word not means. So let's do what's called negating. You ready for that? So let's learn how to apply the first logical operator to a proposition. And once again, the strictness of this kind of varies a little. Wait, why is this not having a very efficient eraser? Okay, do you mind if I just clear the whole screen so it goes a little bit faster? Do you have that mostly written down? Okay, so let's go ahead and clear the whole screen. So let's just say that you have a statement or the proposition that we're going to redefine it to a different value, that Jane is over 21. So it doesn't say she is 21, it says she's over 21. So now what's the negation of that? So what is the symbol not P? It looks really weird. It looks really weird. What's the symbol not P? What does that mean? Yep, that's the simplest way to just say Jane is not over 21. Now, I have seen books before. I've tutored as well as taught out of other discrete math books, and some of them are a little bit more strict than this. There's something called the trichotomy property of numbers. If you say something is over a number, the opposite of saying it's over a number is actually two other possibilities. So what are the two things it could be if it's not over 21? Yeah. So some books are really strict and they say that it wants you to break it down like this. Jane is 21 or less. Like that, because it's equal to 21 or less. That's the opposite of, so the word not is accurate, but it's a little bit vague because you're just putting the word not in. But that's true. Either one of those is a correct negation of, or saying not P. So by the way, this thing right here is pronounced not P, and it's called the negation of P. All right, now let's learn about the next precedence operator, which is the operator called AND. So unfortunately, I should have, wait, oh bother, I should have just made a new page, but okay, let me go ahead and make a different page. And on the new page, I'm going to write the operators again. So there's the not one, the and one, the or one, the implies one, and the if and only if one. So 1, 2, 3, 4, and 5. This one means not. This one, or negation, as it could also be called negation. This one means and. This one means or. Now, by the way, there's also a different kind of or. That's a different kind of or completely. There's another symbol called plus. Hold on, let me write this better. Plus with a circle around the plus. and that's called XOR, and that means exclusive OR. Exclusive OR. Exclusive OR. And this is different from OR. So that's just a separate thing. There's a plus sign with a circle around it called exclusive OR, and it's not the same as the regular OR. And then there's the implies, and then this one's called if and only if. There we go. So it's basically just means equals. That I just think of that as basically being the truth of one thing equals the truth of the other. All right, so and by the way, the exclusive OR actually means not equals, by the way. One thing does not equal another thing. Not equal to. Okay, so let's go ahead and do this. Let's do the and one. So if I say P is you can have ice cream, uh, I'll say have ice cream. Okay, so P is having ice cream, Q is having cake. Then what does it mean if I say that when I went to the lunch that P and Q is what I got? What does that mean? That means that I was having ice cream and cake, right? Okay, now, so that's the second one. Now I'm going down the list of priority. The one is has the highest priority, two has the second, three has the third, and so forth. So the third priority logical operator is called OR. And it looks like, now, by the way, what is this? Do you ever use this thing to mean anything else in everyday life? Like that little hat thing? Like just like an arrow kind of like pointing up to somebody? Like have you ever said something, have you ever said something like in a message board and somebody else says that was dumb? Somebody else puts like a little arrow up to it and it like agrees that it was dumb and then you feel bad? So like it sometimes has other uses besides just the word and. Now let's do an or. Now this one's confusing at first if you're in a real life situation. So what does it mean if I say Q or P or Q? Sorry. What does P or Q mean? Yep, having ice cream or cake. Now here's why it's confusing. This is kind of like in math, the logical things are kind of like being admitted into like the press room or something. So if you have a press credential for like the Associated Press, or if you have a press credential for like Reuters or something like that, you can get in. So if I have both credentials, if I show up to the press room, are they going to say, no, you can't come because you have both? No. So when the word or is in math, the regular word or allows you to have one or the other or both, you'll still be allowed. So when we think about this word or in everyday life, a lot of times we're actually meaning not a logical or, a true kind of or. In real day life, a lot of times we mean an exclusive or. But see, in lawyers and stuff like that, this just means a logical or. So it does not necessarily mean an exclusive or. So in any kind of logic, the word or doesn't mean you can just have one and not both. It means you can have one or the other or both, but you don't even have to write or both because that's logically redundant. So P or Q means having ice cream or cake, but it actually means or both. But you don't even have to write that because when you're in a logic class, that's just automatically assumed. As long as it's not an exclusive or, the word or automatically implies or both. So having ice cream or cake is allowed. And of course, therefore, or both is allowed because either one is allowed, so you could have both. Just like you could have Associated Press, or you could have something else, or you could have both, and you'd still be allowed. Then let's go to the implies. So what does the word P implies Q mean? That's a lot more complicated to understand. So this means that so let me write it out in English. Having ice cream implies having cake. So how many of you would, if you had some really nice ice cream, how many of you would not be happy with just the ice cream? And you just have to go get some cake to go with it? Well, you probably might want some cake, but you might not have to. But let's say if there was somebody that would never ever have ice cream unless they could also have cake with it. So having ice cream for them would always imply having cake with it. Then that's what this scenario means. So whenever I teach this, I try to use the example of working for a friend. Have you ever worked at a job and you need to go like have a birthday party or something? So, or your friend needed to have a birthday party. And so you switch shifts and they worked for you, right? So what I think of this as meaning is like this. Hold on, new whiteboard. So P means that you'll work, or I'll say fill in a work shift for a friend, right? FRIND. And Q means that your friend fills in a work shift for you. So if I say P implies Q, that means that you will fill in that if you, I'm going to put the word if in front of it because it helps us make more sense in English. So if you will fill in a work shift for a friend, that implies, like if you have ice cream, for example, that implies that, now by the word, the arrow just means, and you can change the word arrow to be the word then in English. So then your friend will fill in the shift for you, your shift for you, or whatever, for you. Okay, so that's what it means in English. So this statement right here, P implies Q, translates to mean that if you will fill in a work shift for a friend, then your friend will fill in a work shift for you. So now does that make more sense? So let's just think about that, how that works. So if P implies Q, that means that if I fill in a work shift for a friend, that means that they'll fill in my shift for me. So like if I wanted to have my shift off on my birthday, I would talk to a friend and I'd say, I'm going to do an extra shift for you before my birthday. Then on my birthday, you can do my shift for me. Does that make sense? So one thing implies another thing. Can anybody think of anything that implies something in real everyday life? Can anybody think of anything that implies something in everyday life? So traffic's moving slow, there was a wreck. Okay, so that is a possibility. So traffic moving slow. Traffic moving slow could be called proposition P. And then proposition Q could be called, let me actually say T for this one, because traffic, that's called proposition T. And then there was a wreck. There was a wreck. I'll call that proposition W. W for wreck. T, so T for traffic, W for wreck. So is it true that T implies W? I don't think so, because sometimes it's not always true that every time the traffic is slow, it's not always true that there was always a wreck, right? Would you agree with that? Now, it's probably not also true the other way around either. But is it true though, or is it, I think it'd be more true to say that if there was a wreck, at least on Kellogg or something, that then the traffic would be moving slow, right? So this is probably not always true, but this is more true though. So that if there's a wreck, depending on where it is, but especially on Kellogg though, this is probably more often true. More often true. This is probably not less, this is probably sometimes true, but not always true. Not always true. but mostly true. I'll just say mostly true. No, actually, maybe not even mostly true, but it's kind of true. I'll say kind of true. Kind of true. By the way, what do you call it if you switch the shoes? Have you ever heard of the brand of shoes called Converse shoes? Converse tennis shoes. So they always remind me of shoes. If you switch your shoes onto the opposite feet, you're gonna not be able to play basketball as well, right? So if you switch the shoes to the opposite feet, but you leave the air going the same direction, that's called the converse. So when you're switching the letters in the implies, this is called the converse of the original statement. Converse is taking A implies B and changing it to B implies A. So it's called the converse. So the converse is taking A implies B, switching it to B implies A. They're not logically equivalent. Okay, well, let's go ahead to the very last one, and then we can end with that. In the next class, we can start out diagramming some really cool diagrams called truth tables that help you analyze the logical meaning of things. So what does this mean? A, if and only if B. What does that stand for? Well, let's just say
like you can't have one without the other.
yeah, you can't have one without the other, exactly. So you can't have one without the other. Now, depending on which one you're talking about, it could only apply to one of them you can't have without the other, but maybe the other you could have without the one. But if you said in both directions, you can't have one without the other. Oops, sorry, my fault. If you can't have one without the other in both directions, then that's what it means. So basically that means that if you don't have A, what does that actually mean? This means, meaning that if you don't have A, like that, if you don't have A, then you don't have B, right? Meaning if you don't have A, you don't have B. It also means that if you don't have B, then you wouldn't have A either, right? It also means that if you do have A, then you do have B. And it also means if you do have B, then you do have A. So if A, then B, and if B, then A. So pretty much that all boils down to basically just saying that A equals B. Now they don't use equal signs because that applies more to math. I mean, to like regular math, not logic. They don't really say A equals B like that. They just use a double arrow, which basically in my mind, I just think of that means that the logicalness of A equals the logicalness of B. So like whatever A is the same as B. If you have A, then you'll have B. If you have B, then you'll have A. If you don't have A, then you don't have B. And if you don't have B, then you don't have A. So they're always equal to each other. Does that make sense? So that's where we're gonna wrap up today. And by the way, I might possibly change the homework problems a little bit, just depending on whether I think there's too many of them or the wrong ones or something like that. So you don't necessarily have to start working on the homework yet, but you can definitely start reading section 1. And then on Wednesday, I'll make sure that I have the first homework assignment all finalized by then. So don't worry about submitting any homework or anything like that by Wednesday. So thank you all very much. And have a great day. Look forward to seeing you. And thanks for being such a great class. I look forward to seeing you on Wednesday.
So what do you mean? You know,